Today we are covering lesson 7.5, proportion and similar triangles. Again, our goal is to use the triangle proportionality theorem and its converse. And again, the whole point of this is because we've learned side, angle, side yesterday, and how to show triangles are similar to each other. And we've already learned previous to the quiz that angle, just having two angles and two different triangles will give us similar triangles to each other. So in this case, if GP over PH equals JQ over QK, or GP to PH equals JQ to QK, right? Again, reading them like proportion ratio, then we say GH and JK are divided proportionally. So if you look at it, 4 over 8 equals 3 over 6. That is indeed correct. Okay, triangle proportionality theorem says if we have that parallel line, then the sides are proportional. Now, not getting too in detail here, but if we have parallel lines, those angles are congruent by corresponding, and we already had reflexive right there. Angle R is used in both triangles. So it comes from there, but it's beyond the triangle, right? So it's saying this part to this part, right? So I'm just going to label it for you. It's saying X to Y is equal to, we're going to go A and B here, A to B, right? So that is more specific than just saying the triangles are proportional. So we're going to use that a couple different ways in this lesson. Find the value of X. Now again, we've got triangles, so we're good to say 4 over 8 equals X over 12. Now we can cross multiply and divide. If you want smaller numbers, you could also say 4 eighths is 1/2 before we cross multiply. And we'll get 48 equals 8X, and X is 6. Okay. Moving on. Find the value of Y. We've got the same idea. The difference is they kind of threw a wrench and said, hey, we're going to make the other triangle look really small, but we have those parallel lines. Now, we've got 3 and 9 over here. We've got Y, and this whole segment is 20. Again, the theorem had to do with comparing, right, QP, the two arrow ones, to these two arrows. Right, so what is this side? If this whole segment is 20 and this is Y, this part is 20 minus whatever Y. So now with that, we can do it. We've got 3 over 9. I'm going to simplify right away. We've got 1/3 equals Y over 20 minus Y. Okay, now we're going to cross multiply with our simplified version. 3Y equals 1 times 20 minus Y. We made it a little bit easier. So there's 20 minus Y, right? And so now we're going to add Y to both sides. I'll multiply by 1 there. 4Y equals 20, so Y is 5. Right? Again, you're looking for those triangles, and then the sides that the parallel lines cut into are going to be cut proportional. The converse of this is if we have the proportion, then the lines are parallel. So now basically, if X over Y equals that A over B I mentioned before, then we can say lines parallel, right? Because that's what we're saying. Okay, so basically say, determine whether the lines are parallel. Okay, so we need to check if they're parallel. We are saying if they were parallel, this proportion, 48 over 16, would equal the other side, 56 over 21. We have to go in that order, because we went, from L this way, you've got to go the same idea this way. Okay. Now we can cross multiply. This is a check. This isn't saying it's true. So larger numbers, I take out the calculator, 21 times 48. I got 1,008. I don't expect you to do that in your head. What is 16 times 56? This side is 896 when I multiply, right? Cross multiply to check. These are not equal, so no, it is not parallel. If they are equal, then those fractions are equal. Left side, you could have simplified to 3 over 1. Divided by 7, we would have 8 over 3. Not quite the same. On the bottom, determine whether QR is parallel to ST. Same idea. We're going to 15 over 21. That equals 17 over 23. Cross multiply again. This is a check. Cross multiply. 15 times 23. Sounds like 345. Yep, there we go. 345. 21.5. 21 times 17 is 357. They're close, but they need to be the same. So again, no, they're not parallel. Make sure you have math to back it up, not just a yes or no answer. Next, solving for the variable. We've got 15 and 6, and now this time they have the parallel again for us. We've got y and 14. So again, y was 6 per se. This side would be 8. What did we do? 14 minus y, right? So this little section is 14 minus whatever y is. So y over 14 minus y equals 15 over 6. We can simplify a little bit, which I'd recommend doing because we're going to multiply by 14 minus y here. So I'm going to say divided by 3, we get 2. So this was 5 half. And now I'm going to multiply with that. 2y equals 5 times 14 minus y. So this is a large number here. We get 70 minus 5y equals the 2y plus 5y to each side. And we get 7y equals 70. We're going to go down the bottom, and y is equal to 10. And we're going to arrow back to where that will work. On the bottom, a little bit nicer meter, x over 4, does that equal, solving for x equals 10 over 5. And again, you can always simplify. These numbers are a little smaller, so it's okay just to cross multiply and divide. 5x is 40, and divided by 5. 40 divided by 5 is 8, so x is 8. Next up, a mid-segment. I feel like we've covered mid-segment before. Maybe we covered it in the trapezoid. But here, a mid-segment is a triangle, is a segment that connects the midpoint of our two sides. So our rules are it is parallel to the base, and it equals half of the bottom side. Okay. Key is, to figure this out, is the segment that connects the midpoint, kind of written in the term. Find the length of QF. So basically here we're trying to recognize, do we have the 2 part or do we have the half? So in this case, we're solving for the smaller portion. QS is half of 10. So x equals half of 10. Half of 10 is 5. That's it. The QF section that's in the middle is always going to be the smaller of the 2. If they give us a small part, we multiply by 2. We're going the other way. So, next we've got 8, 8, 11, 11, and we've got 14 and Q. Now these are just different ways, the numbers on the side are different ways to show us it's a midpoint. And if we're saying these are equal but different, 14 is 2 times Q, right? Because the Q is the bigger side, so divided by, I wrote that. Q equals half, equals 2 times 14, right? Because Q is the bigger piece. Just kind of set it up right? So this is always half of the whole. So half of Q, here would be the way to set it up. Half of Q equals 14, and to solve times 2. I'm going to make sure to give you the setup, not just where the answer came from. So again, half of Q equals to 14, so when we multiply by 2, we got 28, which is where that came from. Q is 28. Again, we're given the larger side, so it's the same setup that we just did up here. Half of the long side equals the short. So half of 16 equals P, so P is 8. And there's your assignment for tomorrow, 10 through 29 on page 3.